Of great importance now is the chemical properties of alkenes, and we are going to specifically talk about ethene. So alkenes, they are more reactive than alkenes because of the double bond. This is the functional group, and this is where the reaction takes place. So the double bond, the functional group, is the reactive site. So alkenes are very reactive because of the double bond, because the double bond breaks, because actually we say that alkenes are unsaturated, while we said that alkenes are saturated. Alkenes and alkynes are unsaturated. So if they are unsaturated, they are very reactive. They react. Unsaturated, we said that they can react because they are not stable. But for saturated one, they are stable and they don't react easily. So the first chemical property that the alkenes undergo is combustion. Combustion means burning. So when you burn an alkene in oxygen, it burns to give you carbon 4 plus water. So this is an organic compound. When it burns in air, it forms water and carbon dioxide gas. All alkenes burn in air with a yellow sooty flame. Very important, very, very critical for you to know what we have read here. That all alkenes, not alkanes, all alkenes burn in air with a yellow sooty flame because they are unsaturated. So they burn with yellow sooty flame. Very important, especially in paper 3, to know that when an organic compound burns with a yellow sooty flame, most probably is either double bond or triple bond. You should know that. So most of them, they burn like this. So if this is ethene burns with this and it forms like I have said. So of importance now is the addition reactions. Ethene undergoes additional reactions because of the double bond. We have said that. An addition reaction is one in which one molecule adds to another to form a single product. So we will start with addition reaction number 1, which is halogenation. Like the word suggests, halogenation actually means addition of halogens. We know halogens. We have bromine, we have chlorine, we have iodine. So those are what we call halogens. So this is the addition of halogen atom across a double bond. Chlorine and bromine are decolorized immediately when ethene is added. Equation for the reaction is as shown below. So very important that ethene, when it passed or when it reacts with chlorine and bromine, remember bromine has got its own color, chlorine has got its own color. So when the gas is passed through or reacts with these two, their colors disappear or they are decolorized. They turn colorless. So there's something small I want to show you here. Now when we have a double bond like this, it is important that you know how this reaction takes place. This organic compound is stable because, as you can see, each carbon atom is surrounded with 4 covalent bonds. So when you add chlorine here, the reaction is going to take. So how do we get this compound here? You realize that this double bond first it breaks. How does it break? So 1, 2, you just break the double bond, 1, 2. Then replace the hydrogen ions that were there like this and like that, like this and like that. Now once the double bond has been broken, we have a single bond on the right side, and this single bond leaves us with a gap of the covalent bond. So we have 1, 2, 3. So therefore this chlorine here breaks like this, and one atom joins here to make the 4 covalent bonds, and another one joins it there. And then the name of this compound, because carbons there are 2, is 1, 2 dichloro 1,2 ethane, and the name is 1,2 dichloroethane. You have seen what I have done. So if it is bromine or iodine, so the double bond will break like this. Hydrogen, another one. So plus iodine, for example. So how do you write the equation? Carbon. This double bond breaks. Once it breaks, replace the hydrogens which were there, like this, like that, like this, like this. So iodine breaks into 2. One attaches itself here, another one attaches itself there to make the double bond or the covalent bond to be 4. 1, 2, 3, 4. 1, 2, 3, 4. And the name now is 1, 2 remember for iodine it is called iodo, diiodo, and then 1, 2, that is ethane. Why are we saying ethane? Because there's single bond. If it is a double bond, we call it ethene, but this one is a single bond, so it is called ethane. So when bromine is dissolved in water and then reacted with ethene, the following reactions occur. Now when bromine has been dissolved in water, it forms this compound here. So when it reacts with ethene again, the double bond breaks, and then H attaches itself here, then OH attaches itself here, then bromine attaches itself, and then we have an organic compound we call 2-bromoethanol. 2-bromo-ethanol. The second addition reaction we are talking about is hydrohalogenation. Hydrohalogenation is the addition of hydrogen halides. Hydrogen halides is like HCl, H-bromine, hydrogen bromide. So we have, this is ethene reacting with hydrogen chloride gas. So what happens? The double bond breaks like I have shown you, and then the double bond, this double bond also breaks as HCl. Hydrogen attaches itself here, chlorine attaches itself there, and we have chloroethane, and the name is chloroethane. The next addition reaction is hydrogenation. Hydrogenation is actually the addition of hydrogen gas. So when hydrogen gas reacts with ethene at a temperature range of this in the presence of palladium or nickel catalyst to form ethane. So this one is very important, very critical during when you answer the flowchart, the diagram or flowchart, yes, in paper 2. So this is where we have ethene, the double bond. We have the double bond reacting with hydrogen. So the process here is called hydrogenation. The process is hydrogenation, where now the double bond breaks. But for this reaction to occur, there must be 2 conditions, very critical conditions. Number 1, there must be a temperature of 150 degrees Celsius to 250 degrees Celsius. Number 2, there must be a nickel catalyst. So whenever you are asking for the conditions necessary for this process to occur, you must know that this is hydrogenation. It requires nickel catalyst and a temperature of 150 to 250. So once these conditions are available, the double bond breaks like this. Replace the hydrogen ions that were there. And then now the hydrogen will break as H H because this one is a covalent organic compound. These are, yeah. So one will attach itself there and another one there. And this one is going to be ethane. This one is ethane. So what is the importance of hydrogenation? This process of hydrogenation is used in the manufacture of margarine or margarine to make the oils solid. So we have seen we have cooking oils like chips and we have salad oil. So how are the cooking oil like chips or kimbo made in solid form, while we have other liquids which are in liquid form? Therefore, for the liquid oil to be formed solid, hydrogenation is done in the presence of a catalyst, nickel catalyst, and the temperature of this, the liquid oil is turned to a solid one. The next one we want to look at is self-addition reaction, the one we call polymerization. As I told you, chemical properties of alkenes are very critical when handling the flow chart. That's why I'm taking a lot of time in this one. So self-addition reaction, polymerization. Ethene molecules have the ability to react with each other to form a larger molecule which has higher molecular mass. Each molecule of ethene is known as a monomer. So one molecule is called a monomer. When a monomer combines with another monomer, it forms a polymer. So when many monomers are joined together, they form a polymer. The following equation shows how a polymer is formed. The process in which several monomers combine to form a polymer is called polymerization. So you will see when we are going to deal with the flowcharts, you will realize how simple these things are going to be when you have understood this. So ethene combines with another ethene to form a polymer, and the polymer is called polyethene. If propene combines with propene to form a polymer, the polymer is going to be called polypropene. The polymer is going to be propene. So this one is a monomer plus another monomer forming a polymer. And the polymer of the name of the polymer depends on the name of the monomer. The name of the polymer depends on the name of the monomer. For example, ethene plus ethene is polyethene. Pentene plus pentene, it will form polypentene, and which is a polymer. The process is called polymerization. So whenever you see ethene molecule joined to form a polymer known as polyethene, when you see this kind of drawing, and then it forms this kind of drawing where we have N here, you should always know that this one is a polymer. This one is a polymer. You don't need to wait for anybody to tell you. You need to just know. The next one we want to talk about is the addition reaction with oxidizing agents. We have two oxidizing agents that we use: acidified potassium permanganate and acidified potassium dichromate 7. Acidified potassium dichromate. But these two are oxidizing agents that we use in organic chemistry. When ethene is bubbled through, now ethene is a gas, I told you. When ethene is bubbled into acidified potassium permanganate solution, remember the color is purple. The color of this one is purple. The color of the solution turns from purple to colorless. In other words, we say that when ethene is bubbled through acidified potassium permanganate, acidified potassium permanganate is decolorized. The color turns from purple to colorless. The reason is that this one is an oxidizing agent, so it adds oxygen to the double bond. The manganese 7 ions is reduced to manganese 2 ions and water. Very important to know that. So when ethene is reacting with this is an oxidizing agent, we form this organic compound here. It adds oxygen, like we have said on the double bond. So once it adds oxygen, the double bond breaks to form OH, and this one is called ethane, not ethene, but it's called ethane 1,2-diol. All is for OH. You will learn that in Form 4. When potassium dichromate 7 is used in the reaction, the orange color of the chromate 7 changes to green. So for potassium dichromate, its color, the original color is orange, but if it changes to green, then that one is an alkene or is an alcohol. We are going to know that more in Form 4 alcohols when we are talking about that. The last reaction we are talking about is reaction with concentrated sulfuric acid. So ethene reacts with concentrated sulfuric acid at the room temperature to form ethyl hydrogen sulfate, as you can see here. This is ethyl hydrogen sulfate. When ethyl hydrogen sulfate is added to water and warmed, the product formed is ethanol. So in Form 4, you realize that during the manufacture of ethanol, ethene is one way of preparing ethanol. So this is where it comes from. So ethyl hydrogen sulfate, when you add water, it undergoes what we call hydrolysis to form ethanol. So ethyl hydrogen sulfate is hydrolyzed to ethanol. The process is called hydrolysis. How do you test for alkenes? Or how do you differentiate between an alkene and an alkane? That question will be answered soon. Uses of alkenes, you should at least know 3 or 4 2 uses of alkenes, alkanes, alkynes, all those things. Let us look at this question very fast. Name the following compounds. Now we want to give the name of this compound here. First thing, the rule is count the longest carbon chain. 1, 2, 3, 4. So it is 4 carbon atoms, and I can see the double bond here. So it must be butene. But where is the double bond is? The double bond is on carbon number. I start 1, 2, 1, 2. So this one, even if I start here or here, it is the same. 1, 2, 3, 4. So the double bond is on carbon number 2. Therefore, the name is but2-ene. But2-ene. Let us look at this one. 1, 2, 3, 4, 5. So the name is pentene. But where is the double bond? The double bond is on carbon number 1. If you start numbering here this way, you will be very wrong. So here we will have pent 1-ene, because the double bond is in carbon number 1. What about this? Here we have 2 double bond. How are we going to do that? Very easy. Just first do what? Get the number of the parent name. 1, 2, 3, 4, 5. The parent name is 5. That is pentene, because of the double bond. But on carbon number 1, 2, 3, 4, 5. On carbon number 1, we have the double bond. On carbon number 3, we have the triple. We have another bond. So how are we are going to call it like this? Pent on carbon number 1, comma, carbon number 3, yes, we have 2 double bonds. So 2 we call di, and 1 we call it ene. If there are 2, we call it di-ene. So we are saying that on carbon number 1 and carbon number 3, there are 2 enes, the double bonds. And this is the correct way of doing that. This one is a mirror way, but you can see on carbon number here, we have an halogen. So this is 1, 2, 3, 4, 5. So we will have 1, 2, 3, 4, 5, that's pentene. But on carbon number 4, we have a bromo, so we will start with that. 4 bromo dash, in fact there is no dash, for bromo pent 1, 3 die in, and that is very okay. So I want to show you how to draw the structures of, when you are given the name and you are asked to draw the structure. The first thing we said in alkanes is that to give the parent name. The parent name here is pent. Pent gives you 5 carbon atoms. So you write 1, 2, 3, 4, 5. That one gives us the parent name. The next thing, this parent name, the double bond is in carbon number 2. This one you can count 1, 2, you put it here, or 1, 2, and put it here. So here, so my labeling is 1, 2, 3, 4, 5. I have started numbering from this side. So this is carbon number 2. Again, on the same carbon number 2, there is methyl. So here 1, 2, there is CH. So because it is structural, you a dash, you put a carbon H, H, H. So this is the methyl group, which is written in short as CH3. And then the rest, you put the hydrogen. Just put the hydrogen there, another one there, like that. Like that. You put it considering the fact that it should be surrounded with 4 covalent bonds. You don't just add like an idiot. You need to ensure that you count the number of carbon atoms and the number of covalent bonds. Sorry. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And that is very nice. 1 chloro 2 methyl pent 2 in. So the parent name is pent. 1, 2, 3, 4, 5. On carbon number 1, I can start from here. So this is 1, 2, 3, 4, 5. On carbon number 2, there is methyl group. So there is a methyl group. H, H, H. And then on carbon number 1, there is a chloro. So 1, 2, 3. So we put another hydrogen to make it 1, 2, 3, 4. And then the rest you add hydrogen atoms.